Hi, my name is Andrew Boselli. I'm a senior at Florida State. I'm a student athlete on the FSU football team, and I am a dual major in finance and computer science. The reason why I'm pursuing a degree in computer science is because I would like to get into game design after Florida State. I have a strong interest in systems programming, and I'm currently interviewing for opportunities in Jacksonville and Orlando. My topic for this presentation is Doxygen, which is a documentation generator. This presentation will discuss the history, implementation, configuration, and some of the negative aspects of Doxygen. We will begin with the history of Doxygen. Doxygen was created by Dimitri Van Heesch in October of 1997. Van Heesch had been documenting code by hand, and the current tools available to him were not satisfactory, so he decided to create his own tool. The name Doxygen comes from the combination of the words documentation and generator. Documentation shortened to docs, and generator shortened to gen. The Y in the middle is just for pronunciation. Doxygen was designed for C++, but also supports C, Fortran, IDL, VHDL, C#, PHP, Java, Python, and Objective-C. As for the evolution of Doxygen, it started off rather simple. The initial version, 0.1, was rather basic. Some of the key early improvements were in 0.2, the second version of Doxygen, were function calls and variables being replaced by their links to their documentation, as well as the addition of documentation blocks being able to be placed inside the body of the class. Next, in version 0.3, a search engine was added so you can search through the documentation. This allowed larger projects to be sifted through much more easily. In version 0.4, an offline option for generation became available through LaTeX, as well as full Java doc support. Next, in version 1.0.0, there became added support for templates and namespaces, as well as international support, which was something previous versions did not offer. Finally, we reach our current version, 1.2.0. One of the main improvements in this version is the capability to generate inheritance diagrams, collaboration diagrams, include dependency graphs, included by graphs, and graphical inheritance overviews. These help you visualize different elements of the data and see how they all relate. Another key addition in this version is Doxy which is a GUI front-end tool that allows you to edit and write configuration files for Doxygen. The purpose of Doxygen is to generate comprehensive documentation extracted from source code. Doxygen also has the capability to generate visualization for elements in the source code, as mentioned earlier, as well as generate online and offline versions of the documentation. The online version is generated in HTML, while the offline generation creates a reference manual in LaTeX. Doxygen also has the ability to extract source code from annotated and unannotated source code. When extracting from unannotated source code, the user uses an extract all tag in the configuration file. This will give the user the general idea of the structure as well as what the documentation would look like when using Doxygen. However, it would not be the complete documentation because the code is not annotated. So annotating the source code is recommended. When implementing Doxygen, a major key is the configuration file. Doxygen uses the configuration file to determine its settings. The configuration file is very similar to a makefile. Inside it has tags that control things like what to extract, where to receive the input, and where to produce the output. The configuration file is basically the control system of the Doxygen tool. One of the easiest ways to manipulate the configuration file is by using Doxy a GUI front end used for configuring and running Doxygen. Doxy can create, read, and write configuration file, as well as it is a very, very user-friendly way to configure the Doxygen settings. Because of the many capabilities Doxygen has, it can be very, very difficult to understand and control them all. Doxy provides a very, very user-friendly way to control all of the different tags inside the configuration file. This is key when choosing the style of output you want to use and things of that nature. When creating small projects, Doxygen will automatically search for the source file inside the current directory. However, for larger files that have multiple directories, Doxygen requires you to assign the root directory to the input tag. This will allow Doxygen to correctly identify where to extract the source code from when generating the documentation. And here we have an example of the Doxy Wizard being used. As you can see in this image, there's a lot going on, but the user-friendly kind of interface really organizes all the aspects of the configuration file into a simple way that can be adjusted. If you're looking to the left of the example, you see the file is being named, the source code is being decided, you can choose whether to scan recursively or not, and then the user is able to select what destination they want the output to be generated into. The example on the right, the user is choosing how they want the generation to be formatted. As you can see here, the user is choosing HTML. And then on the far right red box, we have just some of the few tags that Doxygen has, which there are very many. Now, Doxy Wizard is not required. A simple text editor can be used to edit the configuration file, and using the text editor, you can manually kind of go through and decide what tags you want to turn on and off, or assign certain information to. However, there are a lot of tags, and Doxy Wizard is recommended because it puts it all in one simple place that the user can kind of be organized and really know what they are getting. Here we have a general overview of the tool Doxygen, really kind of the entire process that's going on. As you can see, these source files are being read in by the tool, and then the tool uses 3 different files to generate the documentation required. At the top, you can see Doxy Wizard, the recommended way to really create and edit that configuration file, as mentioned earlier. And then on the right, we see the different output styles that Doxygen offers, some of the styles. The HTML file at the bottom is the default method used by Doxygen, but depending on how you alter your tags, you can get a multitude of different outputs. At the top is an XML file. Next, we have the latex file, which is the offline method used. Next, we have a man pages. Then the RTF, which is useful because it has capabilities of Microsoft Word. And these are not the only files that Doxygen can generate, but they are a good example of some of the options. One thing I really like about this slide is it shows truly the complexity of this tool, which is why I mentioned in the previous slide, Doxy Wizard is such a highly recommended tool. Because of the complexity, having something so simple and user-friendly is very key. Now, when it comes to annotating the source code, you really have 2 ways to do it. You can annotate inside the source code or in a separate location. When annotating inside the source code, the user will write a special documentation block in front of the declaration or definition of the namespace, class, or member. The special documentation block tells Doxygen that the special piece of code needs to be added to the documentation. The second method, using a separate location. When doing this, you must use a structural command. What a structural command is a command inside Doxygen that links the entity to the source code. Because the source code is in a separate location, it doesn't necessarily know what is associated with. The structural command does this by linking them. This second method of using a separate location to annotate the source code is useful when trying to annotate something that you can't put the annotation before, such as a file. However, the recommended way to annotate, if you are able to use either option, is the first method, because the second method can possibly lead to duplicate information. Now, looking at these special documentation blocks, they're actually rather simple. It's very, very similar to C++ comments, except for as an additional character. Usually this character is an asterisk or an exclamation mark, but doesn't necessarily have to be. These blocks are what help signify to Doxygen that there needs to be something added to the documentation. As you see in this example, we have what looks to be a basic C++ comment with additional character. The asterisk here, exclamation mark here, and down here there's an extra slash. These first two examples are useful when we have a large amount of text that we need to put inside the block. Whereas the third example is really just when we need one line of text to really explain or illustrate what we are trying to document. Now, the text inside these blocks is added to the documentation with the associated entity as sort of like an explanation. So when you look at the documentation, you see the entity associated with the block, and under it, it will have whatever text you want to ascribe to that entity. This is very useful for complex classes that have a bunch of different elements that need to be defined, or for complex functions that need a little bit more explanation. Here, you can put it inside these blocks, and when Doxygen generates the documentation, it will be there for you or anyone else trying to understand what's going on inside your project to view. When running Doxygen, the user uses Doxygen and then the name of the configuration file typed into the command line. The output format is determined by the tags used in the configuration file. Doxygen generates output in the current directory by default. If a specific output directory is desired, then the user will add the location to the output tag that matches the desired format. As for the negatives of Doxygen, first, Doxygen is a lexical scanner, which means it will not detect any errors in the source code. This is usually not a huge issue because the user should be using a compiler to compile the code. If this is the case, then the compiler should detect any errors. Doxygen is also unable to handle multiple entities, such as classes, with the same name. This will not crash the tool, but only the initial class will be documented, and any other classes with the same name will be left out of documentation. In conclusion, Doxygen was created to document projects of any size in a simple and effective way. Documentation coding before Doxygen was either done by hand or with tools not as capable as Doxygen. By creating the configuration file and annotating the source code, the user has access to documentation generated by Doxygen that is organized efficiently so that really anyone using or working on the code can have a deep understanding of the entities and how they work together. If anyone is planning on doing a project in C, C++, or really any other language supported by Doxygen, it is highly recommended that you annotate the code in proper format for Doxygen so that you can generate documentation very easily. Thank you so much.